Hey Pro Shop professionals, Alex Hoskins here with you. I'm the Research and Development Manager here at Storm, and today I'm really excited to share with you some brand new information on our Storm two-handed layout system, or 2LS. We know that the number of two-handed or no-thumb bowlers has grown exponentially over the last few years. It's really important that we create a new system on laying out bowling balls for them in order to create good ball motion for them now that they only have two finger holes in the bowling ball. That's exactly what this 2LS system is going to do for you, and that's what we're going to look at today. All right, so the biggest thing that's influencing this change in two-handed no-thumb players is the rule change removing balance holes. So before the rule change, two-handed no-thumb players were able to strategically put a balance hole in their bowling ball to increase the dynamics of the bowling ball. Now after the rule change, they only have two finger holes in the bowling ball. The way that we drill bowling balls currently, the finger holes are generally very close to the pin, which actually decreases the dynamics of the bowling ball. And since we only have two holes in the bowling ball now, we aren't able to manipulate those dynamics nearly as much as we could when we had that extra balance hole in there. Like I said at the beginning, the number of two-handed no-thumb players is growing rapidly. These players are going to require a significantly different layout process in order to keep the dynamic integrity of the bowling ball. Like I said, where those holes end up when they're closer to the pin, which is traditionally how we drill for our one-handed players, is going to lower the dynamics or decrease the dynamics of the bowling ball for our two-handed no-thumb customers. So utilizing those same drilling techniques is going to produce much less desirable results for two-handed no-thumb customers, so we need to create a new system, and that is what our 2LS does. The first thing that we need to look at when looking at this new 2LS system, and anything for two-handed no-thumb players in general, is the positive axis point. So if we look on the left side of the screen here, we see our traditional thumb player. Our center of grip is traditionally going to be where the positive axis point is measured from. It's expressed as a horizontal and a vertical coordinate. So from the center of the grip, you draw a line horizontally over and then a line vertically, and your positive axis point is on that line. The center of grip is going to be your point of reference. And this example shows a PAP of 5 inches over and 1 inch down. All right, looking over at the right side of the screen here, we have our two-handed no-thumb players. Now what you're going to notice is the center of grip is in a very different spot than it was for our traditional thumb player. We are measuring the positive axis point for two-handed no-thumb players from the center of the bridge, and that is very important in this system that we use the center of the bridge, because that is also the center of mass removed. We'll get to that a little bit later. Once again, it's expressed as a horizontal and a vertical coordinate. The center of the bowler's grip is still that point of reference. This example picture here shows you a PAP of 5 inches over and 1 inch down. What I want you to notice between these two pictures is that the actual point on the ball is in a very different position, because you're using two different points of reference to reference where that positive axis point is. So it's very important when you're measuring positive axis points and trying to map them back on where they're going to be, you need to make sure that you know what that point of reference is. For our two-handed no-thumb players, that's going to be the center of the bridge. So our 2LS system here, this is a completed example for a two-handed no-thumb player. This is a 5x4x4 2LS layout. Now you'll notice that the format is actually the same as our pin buffer layout system. We have 5x5x4. The last number is not the pin buffer though, so we want to be sure that when you're laying out balls using this 2LS system, that we designate it with a -2LS at the end. Because 5x4x4 using the pin buffer layout system versus the 2LS system is going to give you drastically different results, and you don't want to cross those over for traditional one-handed players and two-handed players. So what you're going to notice in this picture is there is a total of 5 arcs that are used to orient the weight block to the PAP. Most of you are familiar with our pin buffer layout system. We use 3 arcs. 2 extra additional arcs here in order to orient the PAP with the pin and the PSA, and that's what really makes this 2LS system unique and very accurate for our two-handed no-thumb players. Like I said, specific for two-handed no-thumb players. Do not use this with traditional players. You will run into more tracking issues, especially with that thumb hole, because you're going to notice these layouts that are produced with this 2LS system look vastly different than anything that you've ever seen with traditional players. This system uses the center of mass removed to manipulate the weight block dynamics, and that's really what is unique for two-handed players, is now the center of their grip is very close to the center of where all that mass gets removed. If you think about a traditional one-handed player, they might have a very large switch grip, and maybe they don't use inserts. The ratio of mass taken out is going to be different from the fingers to the thumb. Likewise, it could be the other way. Maybe they have inserts and they don't use a thumb slug. The ratio of the mass from fingers to thumb is going to be much different. But if we use the center of our grip here, the player's finger hole sizes are going to be very close to the same, and if they use inserts, the drill bit size will actually be the exact same in most cases, and that's going to give us much more option on what we can do with the dynamics of the bowling ball using this system. So we're going to go through this one arc at a time. So arc number 1, this is the pin to PAP distance. So there's absolutely no difference in this arc from our pin buffer layout system. This number can range anywhere from 0 to about 6 3/4. As we go right in between that at 3 3/8, that's going to create the most overall flare in the bowling ball. The pin to PAP distance controls how much flare is going to be utilized by that core on the inside. So if we're really close to the middle, that weight block is in there at kind of a 45-degree angle. It really wants to tumble as it goes down the lane. It's very unstable as it's rolling. Now, as we lower that distance closer to 0, we lay it down more around the x-axis. It's going to want to be a little bit earlier and a little bit smoother overall. As we go up closer to 6 3/4, we're standing it up very tall, and it's going to want to tumble more through the front part of the lane, change direction a little bit harder off the end of the pattern. Moving on to the second arc, once again, no difference from our pin buffer layout system. Our second arc is our PSA to PAP distance. Nothing could really change about these two arcs here because the pin and the PSA are two very important points on the ball. Where they end up in relation to the positive axis point is still extremely important. It's just where we drill the holes in relation to that that really creates whether the dynamics are going up or whether they're going down. So second arc, PSA to PAP distance, once again, anywhere from 0 to 6 3/4. If you're right in the middle, it's going to be very unstable. As you get that number higher, it's going to want to tumble more down the lane, change direction a little bit harder. And as you go lower, closer to 0, it's going to line up a little bit earlier and be a little bit smoother off the end of the pattern. Now that's in general for asymmetrical cores. Now, if you're using a symmetrical core, this is just going to control the static imbalance to an extent. So if we use much smaller numbers in symmetrical bowling balls, the CG is going to be kicked out a little bit further, which is going to give us a little bit more positive side weight. Now, for some styles of player and on some conditions, that can make a little bit of a difference depending on what they're bowling on and who they are. Now, if we go much longer distances, that's going to kick that CG back to the left, which is more in line with your grip center. Again, that can have different effects on ball motion depending on your style and what you're bowling on. But just keep in mind, it is important on both symmetricals and asymmetricals, and you'll make your decisions accordingly from that. All right, our third arc is where things begin to get different from our pin buffer layout system, and this is what makes our 2LS extremely unique and allows us to manipulate the dynamics for the two-handed no-thumb player significantly better. Our third arc is our pin to center of grip arc. So if you look at the picture here, you'll see that we've chosen a 4-inch distance. Now that arc is going to go back on the left side of the bowling ball. You'll get a feel for this as you do it more and more for your customers, but just note that you will be on the left side of the ball for a right-handed player. Now if you do have a left-handed player your first two arcs will be on the left side of the ball, and your pin to center of grip arc will actually be on the right side of the ball. This number can range anywhere safely from about -1 to about 7. Now this is a really big range, so we need to know what's going to happen when we use different numbers here. The longer that the number gets as we approach, really 6 3/4 is about the maximum that we're going to see a benefit from. We're increasing the total differential of the bowling ball. And we'll go to a slide here next that will show you what kind of effects that we're having. But as we increase that number, we're raising the dynamics of the bowling ball. As we decrease that number, we get down to 3, 2, 1, and even into those negative numbers, we're decreasing the overall dynamics of the bowling ball. So this is going to be the third arc that you're going to draw. Like I said, specific to 2LS layouts, and this controls the amount of post-drilled differential. And that's really important because it's going to orient where the fingers are in relation to the pin, which controls how much or how little change in total differential that we're going to have. This graph may be a little bit confusing to look at, but we'll break it down one variable at a time. So if we go across the horizontal axis here, you'll see that we have the hole distance from the pin. So this is literally just how close the holes are to the pin. On the far left, you'll see we have 0. That's a hole that is directly through the pin. And as we go to the far right, we have 6.5 inches. So this is going to be a hole that's very far from the pin. You'll notice on the vertical axis here, we have the change in total differential. So if you look in the center, we have no change in total differential. And as we go up, we increase total differential. As we go down, we decrease total differential. You're going to notice that we have 4 different line colors here. We have black, which is a 1-inch depth. That's very shallow depth. We have yellow, which is our 2-inch depth. We have red, which is a 3-inch depth. And then we have orange, which is our deepest 4-inch depth. So each of these line colors is representing a different depth so that we can see what kind of effect that's going to have on the total differential. So a couple of things I want you to notice first is take a look at where all those lines cross. You're going to notice they all cross somewhere kind of in the middle of the graph there. At 3 3/8 inches, the hole is exactly the same distance from both the pin and the PSA. So you're actually affecting both of them the exact same, so you see no change in total differential. Now, as you get further and further away from the pin, you'll notice that all of these lines slope upward. Regardless of how deep you drill the hole, it's increasing the total differential if we go higher than 3 3/8 inches. Likewise, if we get closer and closer to the pin, you'll see all those lines actually dip down. As we get closer to the pin, we're lowering the total differential of the bowling ball. Anywhere that we put a hole in the bowling ball, we're raising the RG in the spot that the hole is on. So if we know that the X, the pin, is the lowest RG spot on the ball, and we're putting a hole in there which raises that, we're actually raising the RG and we're bringing it closer to the high RG, the Y-axis or the PSA, and that makes that total differential a little bit less overall. You're going to notice that finger depth either amplifies or reduces the dynamic change depending on what distance you use. And what you can see that is take a look at the black line compared to the orange line. The black line is the shallowest depth, the orange line is the deepest depth. You'll see they kind of trend the same way, but as you go deeper and deeper, that trend gets a little bit steeper and you see a bigger change in the dynamics of the bowling ball. Now we'll move on to our fourth arc, fourth of our 5 arcs. This is going to be our lightning arc. The lightning arc is going to be the 4th arc that you're going to want to draw on the bowling ball. And the lightning arc tells you a lot of things, and I'll show you how we find what the lightning arc is. The first thing that it tells you is the minimum difference that there needs to be in the pin to PAP and the pin to center of grip distances. Just like in the pin buffer layout system, we have some rules that we have to follow. We know that we can't have a pin to PAP distance and a PSA to PAP distance that's less than 6 3/4 because those arcs would never cross. For example, we can't have a 2 by 2 because the 2-inch arcs would never cross since those only add up to 4 and the minimum distance has to be 6 3/4. There's some rules that we'll have to follow here, and we'll show you at the end when we get to the error section, but just keep in mind that this lightning arc gives you that minimum distance. Very specific to 2LS layouts, and it's found using the lightning arc chart. So I'll show you, we did 5 inches on this example. That arc goes from the intersection of those first 2 arcs, so from our PAP, and it crosses our third arc, our pin to center of grip arc. So all we've done is our first 2 arcs, which is no different from the pin buffer layout system, and then we've created another intersection using 2 brand new arcs. This is what the lightning arc chart looks like. There are a lot of positive axis points on this, but as we know, two-handers, no thumb players, they can sit their palm a little bit more freely on the surface of the bowling ball. So their positive axis points can be way more unique than traditional one-handed players that are locked in with their thumb hole. So you have a wide variety of different positive axis points here. You won't run into a situation that you can't find a positive axis point that will work on this. I'm going to show you how this chart works. We'll zoom in on it a little bit. You're going to be using kind of the middle area of it the most because that's where a lot of players will come into play, but it's always nice to have those extras if you do have that unique release. You're able to satisfy them in your pro shop. So we'll take a look at the green example first. So let's say that the bowler's PAP is 5 inches over and 2 inches down. All we're going to do is we're going to look at the top up there, the horizontal PAP coordinate. We're going to go over to 5 inches because that's what their horizontal coordinate was. We're going to go on the vertical PAP coordinate and we're going to find 2. We're literally going to draw where those 2 intersect, and that's going to tell you what that lightning arc distance is. So you can see 5.25, that's 5 1/4 inches. That's what you will use for a bowler with that positive axis point. It's going to be unique based on their positive axis point. So it's extremely important that you use this lightning arc chart. Let's use this black example over here. If the bowler's PAP is 6 over and 3 up, you'll see that that lightning arc distance is going to be 6 1/8. We've gone to 6 inches on our horizontal. We have 3 inches on our vertical. And just note there that it doesn't matter if the measurement is up or whether it's down. It's going to be the same because it's creating what we call a spherical right triangle, and we'll get to that here towards the end of the slide. But you can see where 6 and 3 intersect there is 6.125, which is 6 1/8 inches. So very easy here. All you have to do is line up each one and use that as your lightning arc distance. All right, our 5th and final arc in our 2LS system is our vertical PAP arc. You're going to see that this is specific to 2LS layouts, and it's found by using the bowler's vertical PAP measurement. So literally, if they're 5 over and 1 up, you'll use 1 inch as the vertical PAP coordinate. In our example here, our bowler was 5 over and 1 down. So what we do is we actually draw an arc from the positive axis point, and we have to reverse it because we want the intersection of those first 2 arcs to be where our positive axis point is. So since he's 5 over and 1 down, we draw the arc at 1 inch up from that. This just orients the positive axis point with the center of grip, and it establishes the orientation of the midline. And that's going to be our next step, is drawing the midline. So you'll notice that the midline goes through the intersection of our 3rd and 4th arcs, so that's our pin to center of grip and our lightning arc. We want to go directly through that because that's going to be exactly where the center of grip is for the two-handed no-thumb player. And then on the other side, it needs to be tangent to that 5th and final arc, that vertical PAP arc. This establishes the PAP in the correct position relative to the pin in the PSA, and it maintains that center of grip at the correct distance away from the pin. From there, we're going to draw the center line. Now the center line is going to be perpendicular to the midline, and it's going to pass directly through the intersection of the pin to center of grip and the lightning arcs. This is also going to establish where you can draw the bridge lines, and it really gives you an idea of where those holes are going to go in the bowling ball. Next up, we're going to move on to drilling the fingers. Now, it's very important that we drill the fingers directly off the midline. You'll see in our picture on the right here, we've lined up the center of the drill bit exactly on that midline. We don't need to reverse down or reverse up for a 31/32 drill bit. This is why we use the center of the bridge as our center of grip and our our point of reference. You should always use a sharp grease pencil to ensure that the center of the drill bit is on the center of the midline, because if those fingers are slightly offset, it's going to skew the layout and change that layout dramatically, and I'll show you that on a slide here in the future. One other thing that I will recommend that you do is as soon as you draw the midline on there, you're going to want to circle where those finger holes are going to be, and you want to half it on the midline, because as a pro shop operator, you're going to see that midline and just assume that the bottom of the drill bit needs to hit that. You need to make sure that for these two-handed no-thumb players, we're using the center of the drill bit and we're drilling directly off that midline. So as soon as you draw it over, draw circles on that midline so that you know I need to go directly off of this. You'll drill both fingers, again, directly off of the midline, and the finger depth should be decided based on the desired reaction and the pin to center or grip distance. So we're not recommending the same finger depth in every situation. You could see from our one slide on our pin to center or grip distance that finger depth kind of amplified or kind of negated the differences in the ball reaction. So now that we only have 2 holes in the bowling ball, it's extremely important. One of the only things that we can still manipulate is how deep we drill those holes. So we'll take a closer look at that later when we look at manipulating the numbers, but just keep in mind that you're going to use that finger depth to kind of micromanage the ball reaction based on what you have chosen for the pin to center of grip distance. Here is the finished example, 5x4x4 2LS layout. So you'll see that that's using a positive axis point of 5 over and 1 inch down, and you're using the center of the bridge as the point of reference. So you can see those holes are 4 inches away from the pin, and then we have our 5x4, which is no different from our pin buffer layout system with those 2 arcs on the right. Like I said, very important that all of our lines are very square and we use a very sharp grease pencil. Two-handed no-thumb players have much less consistent positive axis points because their palm can sit much more freely on the surface of the bowling ball because they're not locked into that thumb hole. It's much harder for the pro shop operator to drill lines correctly on a 2LS layout because there's not a thumb hole to line up the prosec to. It's much easier when you have the center of the bridge and you can actually make a tick mark at the center of the thumb hole and you have a very long point to draw your line. With just the 2 finger holes, it's a lot easier to not quite have both of those tick marks centered. So I'd recommend turning the ball at 90 degrees to where the fingers are up and down, make your 2 tick marks, and be sure that that line is dead square to those fingers. We don't want to have two-handed players with offset fingers. We want it drilled directly off of that midline. If you do have a two-handed player that already has an offset, just draw the lines directly through, remeasure your pitches, and start drilling those balls for that player directly off the midline. You'll see much more accuracy coming out of those layouts. The player must also be sure that they pull their fingers and set their palm on the ball consistently from shot to shot. Now, one tip that we've gotten is we have to mark which side of the ball is going to be designated as the palm side. So you can actually put that little tick mark in a spot that the bowler feels on their palm. Makes it so that they feel it on the palm in the same place, they're pulling their fingers the same, and their hand is sitting in there the same, which is going to translate to a more consistent release, more consistent positive axis point, and more consistent ball reaction in general. Here are 3 different extreme layout examples. So we'll start on the far left here. You'll see that we have a 3.5 by 4 by 6.5 2LS layout. Now this is a very strong drilling. It's going to create an extreme amount of flare, the most overall hook that you can create front to back, and it's going to be the best in general on the fresh when they're looking for something to dig into the middle of the lane. Now when you look at this picture, it's definitely not like anything you've probably ever seen before for a traditional player, and that's because if you had a thumb hole that was 4 or 5 inches below these fingers, it would definitely hit on the back flares as that ball goes down the lane. So this is where it is a little bit unique for two-handed players, is we can put those pins in a little bit more extreme positions where we couldn't before because they only have 2 finger holes in the ball. So we're able to do a little bit more even though we have less to work with just those 2 finger holes. Very strong layout example there. We'll go to the middle. That's going to be more our medium example. We have 4 3/4 by 4.5 by 4.5 2LS. This is going to be our medium strength, kind of a moderate amount of flare overall. It's going to give you a good blend of power and control off the end of the pattern. In general, it's going to be best as the lanes begin to transition. Can be good on the fresh, can be good on the burn. This is going to be kind of the most versatile layout. And if you watch the PBA Tour at all, a lot of the two-handers that have been bowling really well in the last couple of months, you'll notice that this looks really familiar compared to what they've been having success with. Last up, we have our very weak drilling. This is a 5.5 by 5 by 2 2LS layout. Very weak drilling strength. It's going to create less overall flare. Very clean through the front part of the lane, and it can be angular down lane if there's enough friction in the back part of the lane, which is going to generally make it better on the burn. You'll notice that that's kind of how we drill bowling balls for traditional players right now. But the difference is the traditional player has a very large thumb hole that's down here, which is further away from the pin, which increases the dynamics of the bowling ball. So if we look back over to our stronger layout, you'll notice that those fingers are actually positioned in a spot where the thumb hole would be for a traditional player with this type of layout. So we're just manipulating where those holes go into the ball. We're utilizing the same pin to PAP and PSA distances, but we found a different way to orient those holes in order to increase the dynamics instead of decrease them. Now that we've shown you all these layout examples and how to lay out the bowling ball, let's physically grab a bowling ball, draw some arcs on it, and lay it out so that you can see each step one at a time, how we're going to go through that decision-making process in order to get the best ball motion for our two-handed no-thumb customer. All right, now that we took a look on the presentation of how to lay the bowling ball out, we're actually going to lay out this bowling ball here. So our bowler is going to have a positive axis point of 5 over and 2 down, measured from the center of the bridge. So the first thing that we're going to do, since this bowling ball is symmetrical, is we're going to draw a line from the pin through the center of gravity, and we're going to mark a spot on this line at 6 3/4 inches. That is going to be our point of reference for our PSA on a symmetrical bowling ball. Keep in mind this is not where there is no PSA on a symmetrical bowling ball prior to the holes being drilled. If this was an asymmetrical ball, we mark this spot with a symbol on all of our asymmetrical bowling balls. So first up, we're going to do our pin to PAP distance. So what we're going to do here is a very benchmark type layout for our player that's come in that wants a layout recommendation. So we're going to use 5 inches for our pin to PAP distance. We're going to use our Storm arc ruler here. We're going to draw an arc at 5 inches from the pin. Now, one tip that I have in using this Storm arc ruler is do not just put the pencil directly down in there without actually using your hand to guide and hold it down, because you'll break the pencil almost every time. 5-inch pin to PAP distance, that's going to be a very benchmark distance for the player. Now, since this bowling ball is symmetrical, the second number is still going to matter a little bit for the static imbalance, but it's going to depend on the style of player and what they're bowling on. If this was asymmetrical, we'd want to take a much closer look at this number. We'll say that our player is pretty rev dominant and he's looking for the ball to be a little bit more forward down lane. That means we're going to use a little bit longer distance here. So we'll go from our point of reference and we'll use a 5-inch distance. All we're doing is crossing our first arc there, and where those points cross is going to be our positive axis point. So no difference so far from our pin buffer layout system. Now our third arc, like we said in the presentation, we're going to draw somewhere in this area of the ball. This is our pin to center of grip arc. Like I said, this controls the amount of total differential that's drilled into the bowling ball. Since we're going to go with kind of a benchmark distance, we're going to use 4.5. So you'll see we put the center of our Storm arc ruler on the pin, and we're going to make an arc at 4.5 5.5 inches. So we have our first two arcs. Where they intersect is the positive axis point, and then we have our third arc, which is our pin to center of grip arc. That's going to control where those fingers are going to be in relation to the pin. Now our fourth arc is our lightning arc. Remember, we have to use the lightning arc chart, and we use our bowler's positive axis point to find what our lightning arc is going to be. Since our bowler's positive axis point is 5 inches over and 2 inches down, if we look at that lightning arc chart, it gives us a measurement of 5 1/4 inches. So we're going to draw an arc from the positive axis point where those first two arcs crossed, and we're going to cross our third arc, our pin to center of grip arc. So we go from the positive axis point, and our storm arc ruler, we go to 5 1/4, and we cross our third arc, our pin to center of grip arc. So you'll see so far we have our first two intersections, we have our second two intersections. This is the positive axis point, this is the center of grip, but now those fingers could be any direction on this center of grip. We need one more arc to orient them to where we get this positive axis point in the right place. That's going to be our fifth and final arc, which is our vertical PAP coordinate arc. Since our bowler was 2 inches down, we're going to reverse that and we're going to go 2 inches up from our initial two arcs that crossed our positive axis point. So we're going to draw an arc up here so that we'll be 2 inches down when we do draw the midline. So we're going to draw an arc from the positive axis point here at 2 inches. Now we have all 5 arcs on the bowling ball. We no longer need our storm arc ruler. What we're going to do is draw the midline. Now remember, the midline is going to be tangent to our fifth arc, and it's going to go through the intersection of our third and our fourth arcs. So you'll see we line it up directly on those, and we go just tangent. Tangent is literally touching that arc in one spot directly through these other ones. So you can see touching in one spot on there, and we go directly through right here. Next up, we'll draw a 90-degree angle, a line at 90 degrees to our midline. That's going to be our center line here. So here's our center line. You're able to draw your bridge lines from there. And like I said, as soon as you draw those bridge lines, really important to just draw your two circles directly off the midline, because as a pro shop operator, you're going to see this line and you're naturally going to want to line that drill bit up to hit the bottom of the bit on that line. If you hurry and you draw two circles on the bowling ball where the finger holes are going to go, you're going to get a much better idea of using the center of the drill bit instead of the edge of the drill bit. And that's very important because you can see the center of the grip, which is right where those arcs crossed, is in the center of the bridge. What you'll notice is we didn't draw the vertical axis line. And this is because we don't use the vertical axis line anymore for two-handed no-thumb players because there's no point of reference on it. We did use it in the pin buffer layout system because we had the pin a set distance away from it. If you'd like to, you can draw it on here. It'll be a 90-degree angle to the midline, and it'll go directly through your positive axis point. So that's what everything will look like. We can recheck this by looking at 0 at the center of our bridge, and we can see our line is directly at 5 over, and our horizontal and vertical, you can see those cross directly at 2 inches down. So 5 over and 2 down. So this is going to give us the layout of 5 by 5 by 4.5 2LS, which is going to be a good overall benchmark layout for your player. All right, now we're going to move on to understanding the numbers, and this is critical. This is some great information for you guys as pro shop professionals, because it's not only going to affect this 2LS system and how we drill the balls for two-handed players, but you're going to get a good understanding of what's happening for our traditional players using our pin buffer layout system as well. So we're going to look at the effects of drilled holes. So with our 2LS, our two-handed no-thumb players in general, the fewer holes that we're allowed to drill in the bowling ball, the less that we can manipulate the dynamics and the ball motion. If we eventually get to no holes in the bowling ball, obviously we can't manipulate those dynamics from what they are out of the box. So the fewer holes that we get in the bowling ball, the less overall we can manipulate it. This makes it even more critical that we understand how these drilled holes are changing the RG value, the total differential value, and the intermediate differential value. Getting a better understanding of how these drilled holes affect the bowling ball is going to allow us to manipulate the dynamics better and create better ball motion for not only our two-handed no-thumb customers, but for our traditional thumb players that use the pin buffer layout system as well. First up, we're going to look at RG. So we have two different graphs on here. I want you to focus on the graph on the left first. You'll see that we have the hole distance from the pin as our horizontal axis. We have the change in RG as our vertical axis. And again, we have four different lines. We've kept the same line colors. 1 inch, our shallow depth, is our black line, and orange is our 4-inch very deep depth. There's a couple things I want you to notice here. The deeper that those finger holes get, you'll notice that those RG values tend to get higher and higher. Now this should make sense. If everybody uses the ice skater example. If their arms are in, they spin very fast. If their arms are out, they spin much slower. Now, if we drill out very deep into the bowling ball and we take out some of that heavy weight block material from the center, we actually make the outside appear heavier. So this is like our ice skater with their arms out. That's our orange line up there. You'll see that those, regardless of where that hole is drilled, if it's drilled deeper, the RG is higher than it would be anywhere else on the bowling ball. The other thing I want you to notice is all of these lines are sloping downward from left to right. Now you'll notice that on the far left, that's the hole that's drilled directly through the pin. So you'll see as we're closer to the pin, much higher RG values overall. If you remember, I said anywhere that you drill a hole in the bowling ball, you're raising the RG in the spot that the hole is at. If we put it directly on the pin, which is the lowest RG value on the ball, we're raising that and we're raising the overall RG of the ball more than anywhere else on the surface of the ball. Now, as we get further and further away, you'll see that we keep the RG value lower and lower and lower. And this is why that pin to center of grip distance is really important, because as that distance gets longer, we keep that RG value a little bit lower. That makes the ball want to read the mid lane a little bit more, be a little bit stronger overall. So you'll notice that shallower fingers are going to result in lower RG values than deeper fingers. So you want to use that depth to enhance the layout that's chosen. Sometimes you might want to go with much deeper fingers for a much higher RG value if that player wants to go a little bit straighter or see a little bit less hook. But other times you might want to use much more shallow distances in order to get that ball to pick up on the lane a little bit more. We'll see some test results on that a little bit later in this. On this other graph here, the biggest thing that I want you to notice is we've changed our horizontal axis to hole depth. So we still have RG on our vertical axis here, but you're going to notice these all look to kind of flatline for a little while, and then they all start going upward at about halfway into the graph here. So you're going to notice once we get to about 2 1/8 inches deep, the RG begins to rise significantly. Now, the 2 1/8 is a number that I want you guys to remember for sure. What's happening once you get past 2 1/8, we have to think about the construction of the bowling ball. So the diameter of the bowling ball is 8.5 inches. So if we were to cut that directly in half, so from the very center of the bowling ball to the surface of the bowling ball, we have 4 1/4 inches. If we cut that in half one more time, so we get directly halfway between the center and the shell, we get exactly 2 1/8 inches. So once we go past that distance, we're actually getting closer to the center of the bowling ball than we are the surface of the bowling ball. Now, another thing that enhances this more is the heaviest and the densest materials are found at the center of the bowling ball in the weight block. So if we bury those fingers deeper than 2 1/8, you'll see that regardless of where we are on the ball, whether we're 0, 3 3/8, or 6 3/4 from the pin, we see that those RG values are going to rise significantly because we're taking that mass out of the center of the bowling ball. Very crucial to pick the appropriate finger depth for what you're trying to accomplish for your player. Next up, we have total differential. The graph on the left should look familiar. That's what we showed you on that pin to center of grip distance. But what I want to show you is this graph on the right here. So we already know that as you drill holes farther than 3 3/8 from the pin, you're going to increase the total diff, and as you get closer, you're going to decrease them. But the biggest thing that I want you to notice is there's not a significant amount of change in total differential once you get past about 2 3/4 inches deep. You'll see that the red line and the black line, they don't exactly V off. They actually turn and shape kind of like a U. So once you get past that about 2 3/4 inch distance, you're so close to the center that it doesn't really matter where you are at the surface of the bowling ball. If you can imagine, if you're directly in the side of the bowling ball, if you're close to the center, the top, you're still removing mass that would be seen if you were looking at it from the top, because all of those axes merge together in the center of the bowling ball. So there's really no benefit as far as total differential is concerned to drill the finger holes much more than 2 3/4 inches deep, because you're not going to see a change, a significant increase in total differential. However, you will see a big difference in the RG value because you're taking away mass from the center. So not a big change in total diff, more RG, the ball's going to get weaker if you drill those finger holes as deep as you possibly can. Can be good in some cases for some players on some conditions, but it's important that you know what changes you're going to have by doing that. Last up, intermediate differential. These graphs are going to look exactly the same. This first one is just mirrored because we're using the PSA as the point of reference instead of the manufacturing pin. So as we drill closer and closer to the PSA, we increase the intermediate. As we drill further and further away, we decrease the intermediate, which would make the ball more symmetrical overall. You'll see that we see the same trend on our other graph here. It's more of a U, not like a V, because as we get closer or deeper than 2 3/4 inches, we're going to not see a huge change in intermediate differential because we're so close to the center of the bowling ball. So intermediate behaves very similar to total diff. It just uses different points of reference. Instead of the manufacturing pin, we're using the PSA as our point of reference. All right, now we're going to move on to manipulating dynamics and ball motion. So this is actually going to be some testing that you guys are going to be able to see this applied in the real world. Most of you might know this guy, Jason Belmonte, positive axis point, 5 1/4 over and 1/4 down. That is measured from the center of his bridge. For this ball testing, we know that Jason can change up all of his bowler statistics, but for this ball testing, he was 18 miles an hour ball speed, 525 RPMs, about 7 degrees of axis tilt, and he was at about 55 degrees of rotation. So the pattern that we chose for this, Broadway version 2, we did use urethane balls in this test, which you are going to see on the next slide, but we wanted to be sure that there was a lot of friction down lane so we could see a big difference in the ball motion as they go down the lane. Broadway version 2, there's a lot of friction in the Storm test facility. You're going to see plenty of difference between these balls as they go down the lane. So Jason's test was all about different pin to center of grip distances, and I've been focused on this the entire presentation. This is our crucial number to determine how much total differential there's going to be after the bowling ball has been drilled, and we're going to see that here. Let's take a look at the ball on the left. We have a 5x4 by 6.5 2LS layout. You can see that last number is very long. If you remember, the further away we get that from the pin, the longer those distances get, the more total differential the bowling ball is going to have after it's drilled. Take a look at our center bowling ball here. 5x4 by 4.5 2LS. You'll notice those first two numbers are held constant, but our pin to center of grip distance has been shortened a little bit to 4.5 compared to 6.5. Then our last one here, once again, the same first two numbers, 5x4, but then we used a 2.5 2LS layout, which gets that pin much closer to the fingers overall. What's unique for us is we have RG swings at Storm, so we're able to swing these bowling balls before to get the dynamics and after they're drilled to see how those dynamics changed with where we put those holes in the bowling ball. So let's focus on the far left there, our first one, our 6.5 inch distance. You'll see undrilled we're at 2.57, 22, and 0. What I want you to notice is look at what happens to the RG value. It actually drops a little bit. This makes sense if you think back to those graphs. This is very far from the pin. One thing I didn't mention is that these holes are all drilled at a standard 2-inch depth. RG value goes down a little bit. Take a look at total differential. We go from 22 all the way up to 28. That's 6 points higher than the original 22. That is a big increase in total diff in a ball that only has 22 total differential to begin with and doesn't have a very heavy weight block in there. You can amplify that even more by using a stronger bowling ball that has more dense material in that weight block. The other important number I want you to see here is intermediate. It goes from 0 to 6. If we have that bowling ball with 0 intermediate after it's been drilled, there's not really anything defined for that ball to spin up to, and it's going to be really erratic as it reacts to the friction off of the end of the oil pattern. Sometimes the rotation might want to pick up on the lane, other times it might just kind of want to scoot right through it, and you're going to see that on one of these 3 bowling balls. 6 intermediate is a good amount of total intermediate because it does give the ball a little bit of something to spin up to, something defined that's going to create a change in direction as it goes down the lane. So that's our very strong distance. We'll go to the 4.5 inch distance. You'll see the RG value goes down, very similar to what we saw with the 6.5 inch distance, but take a look at total differential. We go from 22 up to 26, so not quite as much as we did with our 6.5 inch distance, and this should make sense. If you think back to that graph, as we got further and further away, the total diff went up more and more. So we still increased it, but not quite as much. This is a happy medium between the two. Another big thing I want you to notice, intermediate, still going up to 6. Both of these balls have the holes far enough away from the pin that there's actually kind of going to be something for that ball to spin up to, which is extremely important, especially on these symmetrical bowling balls that don't have intermediate differential already built into them with asymmetry in the core. If we look at our last bowling ball here, our 2.5 inch distance, you're going to see that there's some big differences. 257 undrilled goes up to 2.572. So you can see our highest RG value of all 3 bowling balls with the same size and depth finger holes is our 2.5 inch distance. No coincidence that that is the closest distance to the pin from the holes. Take a look at total differential. We go from 22 down to 17. So now that we're closer than 3 3/8, we're much closer to the pin, we're lowering that total differential, which we know is going to make that ball flare less, stay on a straighter line path longer with the higher RG, and then when we look at this final number here, we only have 1 intermediate. That's not enough or a defined spot for that ball to spin up to, so you're going to feel like, and you'll see it when Jason throws this ball really never looks like it knows what it wants to do as it goes down the lane, and it's really hard to create good ball motion with a higher RG, lower diff ball with no intermediate, especially if they're fresh or if they're hard and there's not a really defined friction on the lane. So we're going to take a look at the performance on paper first, and then we'll watch Jason throw these balls down the lane. So we'll focus on our 3 different line colors here. We have our red line is our 6.5 inch pin to center of grip. That was our very strong one that was very tall. We have our green line, which is our 4.5 inch pin to center of grip distance. And then we have our very weak 2.5 inch distance, which is our orange line there. First thing I want you to notice is look on the left, we have his direction variables. Now, all this is his laydown, his launch speed, and his launch angle. When we do ball tests at Storm, we throw 15 standardized shots in the same place, and we kind of try and take an average of those shots to get everything exactly in the same place as far as the direction of the bowling ball. So if he lays down the ball on approximately the same board, he throws it about the same speed, and he throws it at about the same angle, those balls' trajectories are all going to be on the same general line. So if you look at his laydown here, 24.6, 24.8, 24.8. He's within a quarter of a board for all 3 bowling balls. We know that it's been laid down and very close to each other. Launch speed 18.2, 18.2, 18.3. So very close, within really 0.2 of a mile an hour of ball speed. And launch angle, this is our most important because this is how he's hitting his target in relation to where he's laying the ball down. You'll see 3.1 for all three there. So it's very apparent if you look at the beginning of this graph that all three of these bowling balls were on the same line as they went down the lane. And as they come off the end of the pattern, you can see that's where we see some differences, and that's what we're going to look at with our shape variables here. So our most important shape variables are going to be break point distance. We want to know how far that ball went down the lane before it actually started hooking back to the pocket. The entry position, we want to know exactly where it hit when it got to the head pin, if it got to the head pin. And we want to know the entry angle that it created because we know the mixture of where the position is at the pins and what angle it comes in gives us an idea of how high our probability is going to be of striking. So the first thing I want you to notice, earliest break point out of the 6.5 inch pin to center of grip distance. This had the lowest RG, highest total differential. Makes sense that the red line would hook the earliest overall. You'll notice about a foot later, when we decrease that distance by 2 inches, we go to 4.5 inches for that pin to center of grip distance. About a foot further down the lane, you can see the green line kind of stayed on that straight line path a little bit longer. Take a look at what happens when we get to that 2.5 inch distance. Remember, that was the closest one to the pins, highest RG value overall, lowest total differential, and it didn't have very much intermediate. We can see that ball stayed on a straight line path extremely further down the lane than the other two did. If you look at the entry positions, 18.7, pretty high overall. We do this testing with no pins also so that we make sure that that bowler isn't trying to make subtle adjustments to try and strike. They're purely just trying to repeat shots. So 18.7, definitely a little bit high in the pocket. 17.2, that's pretty high flush. That's probably going to strike more often than not. 13.8, that's not even quite getting there, and you'll see when Belmo throws this ball down the lane on the video that we captured, it just doesn't really know what it wants to do as it transitions down the lane. And what's scary is that's kind of a traditional layout that we like to use for two-handed players, and we're still using even after we lost the balance holes. So that shows you why it's really important that we use this 2LS system to get those holes in a more favorable position overall. Our last number we're looking at, entry angle, 5.24, that's a good amount of entry angle. Even though Jason has a very high rev rate, you got to remember he is throwing urethane, so to create 5.2 degrees of entry angle, very impressive overall. You'll notice 5.5, actually even more entry angle out of that 4.5 inch distance. And that's where, if you remember, I said it's a good blend of power and control. It still gives you a little bit of control of the mid lane, but it wants to go a little bit more sideways off the end of the pattern because the fingers are kind of somewhere in the middle there instead of very close or very far from the pin, which are going to give you very distinct reactions. So 5.58, good amount of entry angle overall for Jason. And if we look at our 2.5 inch distance, take a look, we've lost 1.5 degrees and really 1.25 degrees of entry angle over the other two bowling balls. So overall, this ball is going further down the lane, it's hooking less, and it's creating less entry angle. Overall, that's going to lead to less overall strikes and a lower overall score for your two-handed players. Now, not to say they can't adjust, maybe move a little bit more right and play a different part of the lane, but it's important that we know what these changes in that pin to center of grip distance is going to translate to as we throw these bowling balls down the lane and watch the ball motion. Now we're actually going to watch Jason throw each of these bowling balls. This is what we do after the test. This is the actual visual portion of the test. We always want to see how the balls roll on paper, and we want to see how those bowling balls look to our eye as they go down the lane, because we know different players prefer different shapes. It becomes very apparent what shapes are right and which ones strike more, especially when the pins are up. So we'll start on the left here. That's our 5x4 by 6.5 2LS layout. That was the very high pin, had the lowest RG value, the highest total differential. When you see this ball, it's going to go to the right. It's going to want to dig in the mid lane much more than both of the other ones and go a little bit more forward off the end of the pattern. Let's watch this ball go down the lane. You can see overall that picked up. Remember, this is only 37 feet and Jason has a 525 RPM rev rate. So that's a good amount of early and forward for him to feel like he has control off of the end of this 37-foot oil pattern with that 6.5-inch distance. Now if we go to our 4.5-inch distance, remember that ball is going to get a little bit further down the lane, and it's kind of going to want to change direction a little bit harder. If you remember, that entry angle was a little bit higher on this 4.5-inch distance. Watch how this ball behaves as it goes down the lane in our middle picture here, our 4.5-inch distance. You can see it's a little smoother and later off of it, and look at how much more that ball continued as it went through the pins. You can see it didn't want to get forward quite as fast, and that's because of the position of those holes in relation to the pin. It's more in that kind of in-between zone where it doesn't take a long time to transition and change direction, but it's not so early that it kind of wants to go forward. That's going to be a good benchmark distance for a lot of players. And like I said, a lot of the PBA guys that you've seen on some of these major telecasts lately have been utilizing this and have seen a good amount of success utilizing these medium pin to center of grip distances. We'll move on to our last distance here, 5x4 by 2.5. This was our very close to the pin distance. This is kind of what we traditionally are using for our traditional players that have the thumb, but you're going to see as this ball transitions down the lane, least amount of entry angle, furthest that it goes down the lane, and it really doesn't want to cover very many boards. Additionally, it didn't have very much intermediate differential in it, so it has nothing really defined to spin up to, and that's what you're going to see as this ball goes down the lane. You can see that still got out to the same spot as those other bowling balls did, but you could just see it. It kind of didn't really look like it had any defined change in direction. Now this could have been really good if Jason needed to play a little bit straighter up the lane and there was enough defined friction, but you're probably going to want to stay away from this if the pattern isn't super developed or if the player wants to see more hook in the middle part of the lane. So the pin to center grip distance is going to be the second most important decision that you're going to make when laying out the bowling ball with a 2LS layout. First and foremost, you're always going to want to look at pin to PAP distance. It's always going to be really important what distance we select there, because that's going to utilize how much of the flare of the core that we're going to use. But second, we're going to want to look at that pin to center grip distance to decide if we want to enhance that total differential or if we want to inhibit that total differential. Like I said, distances above 3 3/8 are going to increase the dynamics of the bowling ball. This makes the ball stronger overall front to back, and it'll force the player a little bit more left if they're right-handed. So this example would be our first video that we watched of Jason on the left. Earliest, most forward. Distances below 3 3/8 are going to decrease the post-drill dynamics. This is going to make the ball weaker overall front to back, allow the player to play much straighter up the lane. That example would be our video on the right. Jason would definitely have to move his feet further to the right in order to get that ball to strike. And then if you go somewhere in between, you get a good blend of the two. Now, one thing we haven't talked about yet is short or negative pin to center grip distances on symmetrical bowling balls is not recommended. If you use very short or you even go negative, that's how you create pin in the fingers or pin below the finger bowling balls. We don't really want to do that on symmetrical bowling balls because there's no defined PSA for the ball to spin up to. The PSA is going to spin up in the direction that the holes are drilled in the bowling ball. So if you have the pin 3 inches above the fingers, the PSA is not going to go directly into the fingers. It's going to go in line with the fingers, but it's going to be approximately 6 3/4 away from the pin below those fingers. So if we actually get the holes up above the pin to where the pin is below the fingers, the PSA can spin up to the other side, which will not create good ball motion for our players. Now, if we have an asymmetrical bowling ball that has some drilled intermediate differential built into that design of the core, it's fine to use negative distances because there's already a defined PSA. If you drill those finger holes in there, there's not going to be enough influence to flip it to the other side of the bowling ball. Be careful on symmetrical bowling balls though, because they will get a little bit more erratic. They'll act more like this ball on the right here. So we had one other tester here, Jesper Svensson, 5 3/8 over, 1.5 down, again measured from the center of his bridge. Jesper can obviously change all of his bowler statistics as well, but for this testing, 19-mile-an-hour ball speed, a little bit quicker than Belmo. Rev rate, 575 RPMs, that's extremely high for RPMs. Axis rotation, 65 degrees. and he has about 5 degrees of tilt when he conducted this testing. Again, we're going to use the same oil pattern. This is Broadway version 2. Higher amount of friction on the lane. Jesper's using urethane bowling balls as well. As you move up to reactive bowling balls that have more heavy, dense weight blocks, you're going to see a bigger difference in the changes that are going to happen as that bowling ball goes down the lane. There's more total differential and more intermediate differential in there. So as you put those holes in different spots, that density is thicker, it's going to change those even more, and that's going to translate into bigger differences in ball motion as the balls go down the lane. So we're going to look at the dynamics, and all we did was change finger depths. So on Jason's testing, we did different pin to center of grip distances. On Jesper's testing, we did different finger depths. So on the ball on the left, we have a 1.5 inch deep fingers, so that's going to be very shallow fingers overall. In the middle, we have 3 inch deep fingers. It's kind of somewhere in the middle. And on the right, we have 4.5 inch deep fingers. Those are very, very deep fingers. And you'll see that that's going to change the dynamics of each of these bowling balls. Now you'll notice they're all laid out with the exact same 3.5 by 3.5 by 4.5 2LS layout. You can see the pin and the CG end up in the same spot relative to the fingers. Only difference we're seeing here is finger depth. And like I said earlier, finger depth is extremely critical to decide on based on what you're trying to do with the bowling ball. So let's look at the RG numbers here. 2.57 RG, 22, and 0 is what the bowling ball comes out of the box at. With our shallow fingers, take a look. RG value actually goes down a little bit. Total differential goes up. Our pin to center of grip distance is longer than 3 3/8, so this makes sense that total differential number would go up a little bit. And intermediate differential up to 6. So you'll see, again, we're further away from the pin, so we're creating some asymmetry in the symmetrical core after we drill it. So that's overall kind of keeping the dynamics intact pretty well. Our 3 inch distance, that's kind of a medium distance there. We go from 2.57 to 2.574. So even though these holes are in the exact same spot in relation to the pin, like I said, as we drill them deeper and deeper, we're taking out more mass from the center, which makes the outside appear heavier. Think back to the ice skater that has their arms out. They're going to spin much slower because they're in a higher RG orientation. Take a look at total differential. It actually goes up a little bit more than our first one. Remember, as we drill those holes deeper, it amplifies or it inhibits the amount of total differential in the bowling ball. So since we're greater than 3 3/8, we're actually increasing the total diff a little bit more than we would with those shallower fingers. Take a look at intermediate. We're all the way up to 11, so you can see that's enhancing that number as well. More intermediate means it's going to have a little bit more defined spot to spin up to as the ball goes down the lane. I really want you to notice when we go to the 4.5 inch deep fingers, which is, by the way, the deepest that we can drill finger holes in the bowling ball, you're going to notice RG value goes up to 2.586. This is the highest RG value that we've seen of either of these, and you can see, comparing the first number to the second number, we're literally 18 points different in RG just by getting those fingers to 4.5 inches deep. Big thing I want you to see with total differential, it's the exact same as it was when the fingers were 3 inches deep. Didn't I just say that as the holes get deeper, it amplifies the effect? If you remember back to a couple slides ago, once you get past 2 3/4 inches deep, there's really no benefit to going any deeper. You can see that total differential value in the real world stayed the same as it did in our software engineering program, which gives us more confidence that what we're inputting there is giving us results that we're going to see in the real world. Take a look at intermediate. It acts the same as total differential. As we went deeper, we didn't see a higher amount of total intermediate because we're so close to the center of the ball. 4.5 inches is actually directly in the center of the ball. All we saw was a huge change and a huge raised RG number, which is going to cause that ball to go a little bit further down the lane and change direction a little bit kind of slower as it comes off the end of the pattern. And we're going to see that as Jesper throws these balls down the lane. So we'll look at the performance on paper first. Red line is our 1.5 inch deep fingers, that's our shallow fingers. 3-inch deep fingers, that's kind of in our medium range. And orange is going to be our 4.5 inch deep fingers. Those are our deepest overall. Same thing with Belmo. We have our direction variables, lay down, launch speed, launch angle. You'll see they're all very close. Lay down 21.8, 21.8, 21.8, very close overall. Launch speed 19.1, 19.0, 19.0. Pretty close overall in speed. And you can see his launch angles were all exactly the same. Very high quality lines through the front of the lane. Now you'll notice this graph is going right-handed. We know that Jesper's left-handed. Our graph just always projects the path of the ball for a right-handed player. So just imagine that this is flipped around, but it's going to be the same regardless of which side it's on. It's just looking at it in a mirror or not. We'll move on to the shape variables. You're going to notice when these come all off the end of the pattern, not as big of a difference overall as that pin to center of grip distance. And that's why I said the pin to center of grip distance is really important, because you are going to see very big changes in direction. But just because these lines are close together, don't let it fool you that finger depth isn't extremely important. We did have these balls laid out in such a way that the finger depth didn't enhance or inhibit that total differential quite as much as it could have. But we still want to show you how a small change in direction down here can change to, or can lead to a big change in how that bowling ball goes through the pins. So you'll notice breakpoint distance, pretty comparable overall, only about 1/4 foot difference from our shallowest, which is our earliest, and our deepest, which is our latest. So 39.5, 39.75, and about 40. So as we get those fingers deeper, we're letting the ball get further and further down the lane, and you can see that as that ball on the graph there as it goes down the lane. Entry position 18.7, 18.3, 17.5. So again, our most overall hook came from the shallowest fingers because the RG value was the lowest. It wanted to pick up the earliest and hook the most. Deeper that we got the fingers, the less overall that ball wanted to hook. We look at our last one, entry angle here, 5.5 versus 5.25 versus 5. So as we're getting those fingers deeper and deeper, we're creating less and less entry angle. So just like with Jason's, if that ball is getting further down the lane, it's finishing a little bit lighter in the pocket, and it's creating less entry angle. In general, it's going to strike less and less the more that we trend that direction, and that's really what you're going to see as these balls go down the lane. So let's watch Jesper actually throw these balls. We'll start on the video on the left. That's our 1.5 inch deep fingers. Remember, that kept the RG value the lowest. It's going to want to pick up the most. It's going to give us a nice benchmark look at how that bowling ball is going to go through the pins. Let's watch it. Really pay attention to how that ball goes through the pins. You could see that really wanted to continue, and that knocked them all down 10 directly in the pit. There was no doubt that all of them were going to go down as that ball went through the pins. So now as we go to the 3-inch deep fingers, we get those fingers a little deeper and we have Jesper throw that same line. I want you to notice, remember that RG value is going up a little bit. Total diff did go up a little bit too, but now that we're drilling deeper into the center, it kind of wants to tumble a little bit more. So let's see how that translates. Watch it especially as it goes through the pins. Same spot on the lane. We can see that was a little bit lazier overall as it went through the pins. You could see it still got the 7 out, but you could see it definitely wasn't as defined through the pins, and it kind of wanted to deflect a little bit more overall. If we go to our 4.5 inch deep fingers, we're going to see some big differences in how this bowling ball goes through the pins. Take a look. For a lot of us that don't have 575 RPMs, that's going to end up being a flat 7, a flat 10, pocket 710. Luckily, Jesper has enough power to get both of those out, but you can see the deeper that we got those holes, it delayed that hook a little bit and made that ball get a little bit more forward. So again, not a huge difference on paper there, but now when we put those pins up and we actually watch the ball go through the pins, we see some big differences in ball motion and continuation through the pins. Jesper's obviously going to be drawn much more to that first ball motion compared to our last one, which was our 4.5 inch depth. So the big thing on finger depth is don't think that it affects the ball motion the same based on the same depth. So if pin distances are closer than 3 3/8 to the holes, shallower fingers are going to reduce differential less than deeper fingers. So basically what that means is if you put the fingers closer to the pin, if you drill those holes shallower, you still are going to lower the differential, but you're not going to lower it as much as you would if you buried those fingers. So if you really want to kill the total differential of the bowling ball, drill it very close to the pin and drill them really deep, because that's taking and making that weight block, instead of being taller than it is wide, you're taking a lot of the mass out of the top and you're making it look more like a circle as it's transitioning down the lane. Now likewise, distances that are further than 3 3/8 to the hole, shallower fingers, they're still going to increase the total diff, but they're not going to increase it as much as deeper fingers. And then keep in mind, we have our two distances that are really important for finger depth. We have 2 1/8, which is where the RG value begins to go up very quickly, and we have 2 3/4, where if we go deeper than that, total differential and intermediate differential don't go up very much more because we're very close to the center of the bowling ball. As the fingers get deeper, the RG value is going to go up regardless of the location. This is going to cause later and less overall ball reaction in most cases. So don't get trapped into thinking, oh, just because I'm further away from the pin, let's say I pick a very strong 6.5-inch pin to center of grip distance. If you bury those fingers, yeah, you're going to have a lot of total differential until you get to 2 3/4. But as you go deeper than 2 3/4, you're just going to start raising the RG and kind of counteracting what you're trying to accomplish. So that's why I say it's really important to keep those two numbers in mind, 2 1/8 for the RG and 2 3/4 for the total differential and the intermediate differential. Okay, like I said, we're going to have some warnings and recommendations with any new system. You're going to have to get a feel for it, because there are some directions that you can go a little bit too far and you can actually start seeing some negative results. So we need to be sure that we know kind of where we need to stay to be in a safe zone until we feel a little bit more comfortable with what results we're seeing for different kinds of players. We know that everybody bowls a little different, so we got to be sure that we take into account all those different styles. So you'll remember at the beginning of the presentation I said that you can run into some errors. We know with the pin buffer layout system that you can't have pin to PAP or PSA to PAP distance that doesn't add up to 6 3/4. If you had like a 2x2, those arcs aren't long enough to ever cross at any point. So they need to at least add up to 6 3/4 so that they'll cross at some point. Additionally, we can't have a pin buffer that's longer than the pin to PAP distance. So what we have with our 2LS system is what we call low and high RG errors. So if you're doing an extreme low RG layout or an extreme high RG layout, there's a chance that the arcs could not cross. And I'll show you an example here. We'll focus on the left. We have a low RG error first. So our layout is 2x6x6 2LS. And let's say that our bowler has a unique release that gives them a 3-inch lightning arc distance. So the way that you'll encounter a low RG error is if the selected pin to PAP distance is too short and the selected pin to center of grip distance is too long for that lightning arc to cross. Now what does that mean? A really easy way to look at it is look at the first and look at the last number. Whatever the difference between those two numbers is, has to be what the lightning arc is. So you'll see we have 2 and we have 6 in our first example there. The difference between those two numbers is 4. So if our bowler has a release that only gives them a 3-inch lightning arc, when we go and we look it up on that chart, the 3-inch lightning arc is smaller than the difference between those two. It's never going to cross. If you look, we have our PAP on there, very close to the pin because it's a low RG layout, but now we've selected a pin to center of grip distance that's very long, very far away from the pin, and you'll see when we draw that lightning arc, it's not long enough to ever reach it at any point on the ball. So we need to make sure that the difference between the first and the last number is at least that lightning arc distance in order for that to cross at some point on the bowling ball. Likewise, you can have the same error, but on the high RG side. So that's when the selected pin to PAP distance is too long and the selected pin to center of grip distance is too short for that lightning arc to cross. So again, first and last numbers, we'll use a different lightning arc in this example, 3.5 inches. We have 6 and we have 2. Again, the difference between those two is 4. So 3.5 just isn't quite going to cut it. You can see we have our PAP, which is much further away from the pin now. We have a much higher RG layout. Our pin to center of grip distance is very short. You can see when we draw the lightning arc, it's not long enough to ever cross it. So the big thing to look at on these errors is just making sure that your first number, pin to PAP, your last number, the pin to center of grip, is at least the difference between those is at least the lightning arc's distance. This is not going to happen very often, but it's important that you keep this in the back of your mind, because if you're laying out a ball in front of a customer, you don't want to run into this error and kind of be second guessing what you're doing. So it's only going to happen on very low RG layouts or very high RG layouts, and a lot of players have lightning arc distances that are pretty long, so you're going to be pretty flexible in what you're able to do on this. Like I said, it's very important to use the lightning arc chart. What I want you to notice here is we'll start on the picture on the left. We have a 5x4x5 2LS layout. Let's say this bowler has a very unique PAP of 2 7/8 over and 3 inches down. If you map that out, you'll notice that the lightning arc needs to be 4 inches long. When we originally developed this system, we were just hoping that you could use the horizontal bowler's coordinate because that would be a lot easier. But as we have a larger and larger vertical coordinate for the bowler, it creates what's a spherical right triangle on there. So we have to use some geometry in order to trace back and decide what that bowler's horizontal coordinate is going to be. So if you just used 4 over for your lightning arc and then you measured down, you could see if you measured back over, it wouldn't be, the PAP would not be in the correct place on the bowling ball. Same thing on this second example here. We have a 5x4x6.5, different PAP. You'll see 4 3/4 over and 2 inches down. You'll see that our lightning arc that we used is 5 inches. What I want you to notice is this is only 2 inches, the vertical distance, where it was 3 over here. Look at how much different the lightning arc is from the bowler's horizontal measurement compared to this. That's why it's really important that you use that chart, because there's not just a conversion. It's not to say that it's always going to be a 1/4 inch less or a 1/2 inch less. You can see it's 1 1/8 inches less on that example, and it's a 1/4 inch less on that example. And that's going to change. So it's extremely important to use that lightning arc. The midline, the VAL, and the lightning arc all create that spherical right triangle. The lightning arc's the hypotenuse, so we're able to use some spherical geometry in order to find and work backwards to get the bowler's horizontal PAP coordinate. Another really important thing to consider is the position of the bow tie. Every bowling ball is going to have a top bow tie and a bottom bow tie. Both the top and the bottom bow ties are going to fall equidistant from the bowler's PAP and every point of axis migration as that ball goes down the lane. This distance is going to be determined by the bowler's axis tilt. So an easy way to think of it, in general, pin up layouts are going to migrate across or even up a little bit. So that's going to cause that bow tie to be a little bit higher overall on the top, and the bottom bow tie is going to come up closer to the thumb hole. As we use pin down layouts, they're going to want to migrate more downward, which is going to cause the bow ties to come down and further away from the thumb hole, much closer to the fingers. That's why if you have some bowlers that don't have very much axis tilt, they can run into actually hitting the finger holes on some layouts that are pinned down as that bowling ball flares down the lane, especially because they don't flare as much either. So lower amounts of axis tilt are going to cause the bowler's bow ties to be closer to the PAP. Higher amounts of tilt are going to cause it to be further from the PAP. Now, why does this matter? It's because we can use all these different pin to center grip distances, and we need to set some limitations on where the ball can safely flare without hitting the track flares created by those bow ties. So we have a very extreme example here of a 6x4x10.5 2LS layout. We're not recommending this by any means, but we do want to show you how you can create some unique ball motion and some very different layouts than you ever have before that can possibly solve some problems that your customers may have had. Like I said, we don't recommend extremely long pin to center grip distances. 6 3/4 is going to be about the maximum benefit that you're going to be able to get out of it, because that's directly in the side of the ball. As you go higher than that, you are getting further away from the pin, but you have to remember there's a positive pin and a negative pin on the bowling ball. So if you're directly in the side at 6 3/4, you're as far away from both as you can get. As you get further and further, you're actually just approaching the negative pin of the bowling ball, so you're not going to see the total differential value keep rising. And if you remember those graphs on there, they did level out a little bit once we got close to 6 3/4. When you combine these very long pin to center of grip distances with some stronger or even longer pin to PAP distances, you can run into tracking issues for two-handed or no-thumb players because of the position of those bow ties. That's really bad for us because we don't have balance holes anymore. We can't manipulate where that track's going to go. We're going to have to plug those holes and restart for that player. To avoid tracking issues in most cases, the distance from the manufacturing pin to the center of grip should never exceed about 8 inches. In most cases, you're going to be safe there. But like I say, as you get longer and longer, really take into account what bowling ball you have, how much rev rate, axis tilt, and rotation that your player has, and determine kind of what the limit is. You can see that with this particular player, we were able to go up to 10.5, but you can see how close that's starting to get to those fingers, and there's really not a huge benefit of going past 6 3/4. So like I said, the safe distance anywhere from about -1 to 7, but you can go a little bit more if you want to try and see something a little bit more extreme. Last thing that we didn't talk about is our negative pin to center of grip distances. Negative pin to center of grip distances are used to create pin down layouts. Did kind of touch on this a little bit earlier. We're not recommending this on symmetrical equipment for two-handed no-thumb players because the ball doesn't have a strongly defined PSA after drilling. Like I said, the PSA is kind of going to want to follow where the holes are in the bowling ball, and especially if it's symmetrical and there's no intermediate drilled into the core, in the technology of the core, this PSA could actually flip up and go the other direction. It's going to make the ball really inconsistent as it goes down the lane, and it's not going to have a very high amount of post-drilled intermediate differential. Really hard to create good ball motion if it kind of doesn't have anything to spin up to as it goes down the lane. Another thing is these types of layouts can lead to tracking issues. For many players with higher tracks, we know a lot of two-handed no-thumb players do have a little bit higher tracks. They have less overall tilt because their thumb and their wrist is in a spot that they're able to get kind of around it a little bit differently, and we're not able to adjust with the balance hole anymore. So we kind of want to avoid these because since we can adjust it and there's really no benefit to having it below versus 1 inch above, we're just kind of going to stay away from that to create more consistent and better ball motion without running into the possibility of hitting the holes. All right, guys, that concludes everything about our brand new 2LS system. As always, we here at Storm appreciate your support and your business and your loyalty over the years. If you guys have any questions or concerns, I know there was a lot of information in this presentation, feel free to reach out to us. We have a full-time technical team. Feel free, you can give us a call at 435-723-0403, or you can send us an email at tech@stormbowling.com. Like I said, we employ a full-time technical team that's always able to assist you with any questions or concerns that you might have. Have fun out there and bowl up a storm.